So we're 2 minutes in. Let's start this off a little bit. Tomer, to introduce ourselves. Um, Please, sir, if you don't mind.
So I'm Tomer. I'm one of the founders of TAG and also acting as the CEO. And I'm writing software for our industry for about 15 years. HDR is just one part of this very complicated field.
Thank you. Robert Erickson. I'm the vice president of sales for TAG. I've been in the live production domain since, man, I'm getting old now. 25 years. Wow, it is 25 years. I started off in the news world and then spent quite a bit of my career in the sports and live production side. So HDR for us has actually been quite passionate. Um, Over the past about probably the last 12 to 18 months, because the industry has been so keen and been pushing HDR so much. The industry has definitely gone through its phases over the years. We went through 3D. Thank God that was short. We did 4K, but we are largely seeing that at 1080p, 60 for the US, 50 for the rest of the world. HDR seems to be the best mix of bandwidth and quality and so forth for the best user experience. And because of that, we've seen the industry make great pushes into HDR over the past couple of years. Now, with any new technology, there's new workflows that are designed and new requirements that come along with it. And also with HDR, because there is no mandate, there's all sorts of different types of formats. So, if we go through the typical alphabet soup, you have HLG and you have PQ, and then of course you have the basics of why we hear HDR. And you have wide color gamut. Things like that, Rec 2020, what's the difference between that, Rec 709, and so forth. So we're going to be addressing some of these today. And again, as we go through, if you have any questions, feel free to put them into chat. But today is all about how, as an industry, do you manage all the different parameters and all the different potential quality issues and also mistakes that can happen in your HDR workflows? What tool sets are available, but also trying to identify some of the complexities that come along with it. Because part of HDR is you want it to be as objective as possible. But unfortunately, due to humans and the monitors and the equipment you use, it's highly subjective to the individual user. And that's kind of what we're talking about today is how do you have a tool set? How do you create an entire production workflow to be able to stick to the science, stick to the math, be able to stick to the most basic elements of quality and its reproduction thereof in your workflow. So, to start off, Tomer, let's talk about the differences are some of the challenges we're seeing in HDR and SDR workflow. And one that I'm kind of passionate about is even how can people, like, you have two different monitors in front of you. I think actually right now is a really good example. You have a very high quality production output monitor that I can't see that's going to have video and audio looking great. And then, of course, we're going to be looking at this through, whatever $200 monitor I have, which is actually what a lot of the broadcast industry uses. So what's some of the challenges people are seeing with just how they view HDR content and SDR content and so forth?
So I think that first of all, we need to differentiate between a live production HDR and HDR for VOD. Because for VOD, as we all know, HDR exists for some time and everybody can watch movies on Netflix in HDR. So over there, it's a completely different story because you have all the time in the world to fine-tune everything. Now, when you're talking about live production, then you don't have a second chance to fix stuff. It's live. And then it's very important to be prepared to the live production and knowing what are your tools and how it will look and how it looks everywhere else, because you don't have the ability to test it in multiple different scenarios. You have a single stream that you're sending, and you want to be sure that it's the most perfect stream. Now, another parameter that you talked about, that HDR live production just starts in the last year or so, I think that also part of it is related to monitors. As you said, different screens can display different colors and different quality of colors. And it's true for consumer grade screen, also for the professional ones. But obviously, if the consumer doesn't have a screen that can utilize what you're sending, there's not much sense in sending it. And in the last few years, we see more and more OLED displays and high quality displays where they have an ability to display more, to display brighter colors and more colors. So it makes more sense to produce in HDR. And also, once your screen is more dynamic, you can also see more issues with your HDR. Obviously, if your screen is blurry, you wouldn't see all of the problems. So then we're going to the production itself. You can't have the same screen everywhere. You can't have a single type of screen. You can't have the same screen in the same parameters all the time. So you need to be able to validate your production configuration using common tools which are not necessarily the screen itself, not necessarily what you see on the screen. Because as you said, everybody can decide that they have a different taste or flavor. This is called the artistic part of it. So not necessarily everybody will decide that they want the scene so red or so green or so vibrant. So there are a set of tools which enable you to mathematically measure what you're doing, measure and compare.
And that's the part I think is most interesting to me is that mathematical basis, because we've seen a lot of tools in this industry that are, I'm just going to basically take a slate, I'm going to put it up on the screen, we're going to pass it through, call it done. Or I'm going to analyze one channel of video and call it done, which is fine for that, single channel video. But the reality is a lot of our production workflows are incredibly more complex than that. So having a tool set that's able to look at the video, look at the luminance, look at the chroma values, but also the metadata, I think is really, really quite important. So as a general kind of a knowledge to everybody on the webinar, this right here is kind of what we consider a kind of a fundamental tool set. Some of this, especially the OG broadcast engineers, will recognize the waveform vector scopes on here, but also there's some newer tools and newer ways of using these tools that are different in HDR workflows. So I guess as a good start off on this, Tomer, what are we looking at? Like, what's the individual elements here, and what's the relevance to everybody on the call of why does it matter, and how does this integrate into their production workflows?
Okay, so we have the waveform monitor, the graph, which displays the luminance over the lines of the frame. It enables you to see the dynamic range of your luminance of the frame. If you have issues in some places, if it's in the right scale. We'll talk about how you use it to compare between different formats later on, but this is what this graphs give you. You have the parade, which is an RGB brightness display, separate per channel. So the YUV frame is converted into RGB, and the same mathematics as the waveform display is being done per color. We have the histogram display, luminous histogram display, which is a graph which showing you where is the majority of the pixels of the frames are located, bright, dark. You can see the maximum brightness of the frame and so on. And you have the same thing also for the RGB parts. So if you have a bright white scene, you would expect the RGB parts to be similar. This enables you to tune your colors. And mostly important, it enables you to keep the same behavior over different formats. The vector scope is the round one here in the top right, is a display of the colors themselves. Again, it's like a two-dimensional histogram where the colors are located. If you have very red image, you'll see that it goes to the red side and so on to the green. You can see the range of the colors, not just what are the colors. And again, when we'll talk about the comparison, we'll see exactly how it can be used. Now, all of those tools are like, as you said, normal common tools, nothing new here. The main difference is when you're talking about live production today, live production in the end ends at the customer side. And consumers today consume their content over OTT protocols. And those OTT protocols are a result of re-encoding of your uncompressed content into ABR encoders, different encoder types, different bit depth, resolutions, and so on. And all of the classical tools for those measurements are done on the SDI side, on your ingest. Now, if somewhere along the way, one of those parts of the encoder packager in the manifest, some small metadata was missing, suddenly everything will be off. And this is one of the important parameters of these tools. The abilities of these tools is also to monitor on all of the formats, also on the return channel on the OTT, after all of the processing in the middle. And this is very important. Why? Because this is in the end what you're sending to the customer. This is where you really care about what's going on.
So yeah, along those lines, let's talk about that a little bit because I know everybody's like, oh, I'm sick and tired of hearing about metadata. But I think that's actually really important. But I also think that's really important about your HDR tool set because there is a lot of tools out there in the IP domain that can do HDR kind of quality and analytics, but only in the 2110 domain. But I think that's a very limited scope because if you look at what it matters to the user and what matters to the consumer at home, isn't just, how is the signal at its, uncompressed peak quality, but, what happens to the signal once it goes into an encoder and what happens to that signal post encoder? What happens when it goes to a CDN? Is the CDN doing something when it's re-encoding into HLS and pushing that back out and so forth? So having that tool set that is not just 2110, but having a tool set that can decode and manage almost any modern transport. So HLS, NDI, SRT, I don't need to name every format that we support, but I think having a tool set that's able to do multiple different types of codecs and also multiple different types of transports is basically required now. Because again, if you just look at it at 2110, when it leaves the production domain, which is fine, but that doesn't at all cover any of the workflows, that is the distribution, your OTT, things like that on what actually matters to the user, which again, back to metadata on this one, really becomes kind of a big deal because talk about a little bit on your side, at least on your thoughts on metadata, because we have so many things like HDR10, HDR10 plus, Dolby Vision, all those different types of metadata, and even the SDR feeds that we still have to preserve. What do you see the role of metadata and be able to decode that and feed that into that data back to the users being?
Yeah.
Is that pretty key?
So metadata is used mainly in VOD, where you have a producer which creates the content, decide what to add and where, and he has all the time in the world to do it. In live production, we see it less because what is the metadata? What is it used for? In the end, this metadata doesn't really affect the picture that you're sending at all. You're sending values per picture, per pixel. This value per pixel is not affected by the metadata. The metadata is used by the receiver, either the receiver, the set-top box, the TV, whatever, wherever you decided to implement it, is being used in order to optimize the display of this picture. If you have the best screen in the world, you don't need any metadata because your screen can show true black and true white and everything in the middle and is very fast and it can do everything. So you don't need any metadata. It's perfect. But if you bought a $300 consumer TV, then this TV can't show 1000 nit white on the left side while showing a true black on the right side, or maybe it can. But if it can't, then this metadata tells the screen, okay, now we're going to have a very bright scene. So let's push the backlight of the screen. If it's not an OLED, let's push the backlight of the screen and utilize it to show a very bright screen, scene. And the same is for color calibration or color balance. If you know that your screen has limited red and you have a scene with lots of red, you might try and balance a bit the scene to a different color in order to have more grade in the red. In the end, our eye is very flexible. The eye sees everything as relative. So by having those relative references in the screen, you can create a higher dynamic range. And this is where the metadata comes into range. So you have a static metadata for VOD or dynamic metadata. The difference is with the statics that it sends it once in a program. It tells, yes, it's a dark program, a bright program, or whatever. And dynamic one is really in the resolution of a scene, maybe even in frame resolution. But the main problem is how you create this metadata. So there are some vendors today that have has devices for automatic creation of those metadata information for live content. But in general, this is mainly for VOD recorded stuff. Less used today for live content. In the future, everything is possible.
So let's take that as a segue, actually, about the live production workflows. So right now, you're obviously showing us a PQ, just because obviously the huge PQ that's on the UMD. But reality is most of our
Let's
live
explain
production.
what is a PQ. Maybe,
Please.
So we have the SDR color space where the colors themselves are limited and the brightness is limited according to TV sets from about, I don't know, 10, 15 years ago, what those TV sets could have displayed. So the standard is matching this ability. Now, since TVs today can show more colors and more brightness, we have the two different standards, the HLG and PQ, where in both, the color is much wider, meaning you have more red, more green, and more blue range. And also you have a higher brightness peaks. So PQ is a logarithmic scale, meaning that it's not linear. You have a greater gap between the values in the very bright pixels because your eye can't really differentiate between 1000 nits or 1000 or 1100 nits. We look probably the same. You don't need the same granularity and resolution as you need in lower values. So it's not nonlinear. And HLG is nonlinear only on the edges, only on the very bright white and the very dark black, meaning that in the middle, it's kind of similar to SDR. So it's very simple to convert HLG to SDR. And even if you look at HLG in regular SDR screen, it looks okay. Only the very bright white and dark blacks are a bit off, but except for that, it's kind of okay. PQ, if you don't have a PQ screen, you have if you interpret the content as SDR, you'll see a very washed out gray picture.
For what it's worth to the larger group, since I'm just going to randomly throw my opinion in here because I can. I'm personally, I have a proclivity towards PQ. I think it's actually the best quality out there. Obviously it's based off of a ton of research on the eye's visual acuities, how humans interpret the concepts of light and brightness and so forth. I personally love PQ, but HLG is easy to produce because you can use existing monitors and a lot of existing gear on HLG, which is quite interesting, which is a good segue for us, by the way. For everybody on the screen watching this on Zoom, just FYI, Zoom does reduce the resolution quite a bit, both temporally and also in the resolution itself. So if you see something being soft or whatnot, then apologies for that. But it is Zoom. For me, it's looking pretty good, but we've had a couple feedbacks from some that are having some reduced resolution.
It's also part of the demonstration. We are playing an HLS feed on a browser, capturing it in PQ on a PC, capturing it and sending it over Zoom. And you have tools that you can analyze the colors, over a remote Zoom.
So it's almost like we've designed this to work in remote production environments and live. So to that point, actually, I guess we could segue to the next layout you have, which is the comparative one between SDR and PQ. And for a majority of the live productions, this is the reality of what you have to do is you have to create two entire production chains. You have one that's your standard dynamic range, which feeds your normal cable providers, feeds your satellite providers, feeds some of the OTA, people that are stuck with 8-bit or that type of production workflows. But now that so many people have the ability to stream to the home, 10-bit, high bandwidth, different kind of codecs and so forth, the reality is almost any production you're doing today is going to be a mix of SDR and PQ. So, Tomer, kind of explain right here, I love the fact that we have a comparative tool set now where we're able to look at an SDR and a PQ thing. What's the value to this to the operator, you think, as a QC operator or as an EIC in a truck or whatnot?
Okay, so here we're seeing side by side on the left, the SDR stream, and on the right, the PQ. In this case, our mosaic output is being generated as a PQ. So it means that the PQ part of it is untouched. The values of the pixels are untouched, are the same as they are. and the SDR is the converted one. Usually, when you need to select one mode where your multiview will work in. It can have half the screen, half the screen in different formats. So you usually will go to the higher quality one. Obviously, if you have a multiviewer in SDR and you're producing PQ, it's a waste of energy because you wouldn't see anything. You wouldn't see the problems. So you would use a multiviewer in the native format of the higher quality variants that you has. And then you would like to see what is the result of all of the conversions of this color space. So in this case, we have the PQ and we have a conversion to SDR, and we're seeing them side by side. So the multiviewer is changing back the colors of the SDR to fit a PQ monitor. So if you look at an SDR content on a PQ multiviewer or on an SDR multiviewer, it should look the same for you, for your eyes on the same type of screen. So based on that, visually, you can see that the frames looks the same. It's not washed out. The colors are not distorted too much and so on, as you can expect. Obviously, the picture can't be exactly the same because if it would, you wouldn't need HDR. You need HDR because you can show things that you can't do in SDR. What we see on the graphs. On the graphs, we see very immediately on the let's say on the Luma graph, you currently can see that the PQ is not utilizing the whole PQ range, which is up to 10,000 nits. This content is using only up to 1,000 nits. And you can see on the SDR that it's using 100% of the luminous range. And most of the things you can see that it is in a higher value bit. So you can see where some of the content that you see on the PQ is being not displayed on the SDR, being washed out. If you see on the very bright scenes, you can see that the PQ is using higher brightness, and in the SDR, it's like kept on this end. When you're doing the production, if you do care about the SDR, you might want to tune everything in order not to be out of those boundaries, or at least know when you are. You can see that the dynamic range of the waveform monitor, again, limited to 1,000 nits on the PQ, if this is what you expect to produce. And you can see that you're using the whole scale on the SDR. If we would have converted SDR back to PQ and displayed it, we would see that the PQ range would be much more limited, because you can't, build what you didn't have on the SDR. And this is also an important parameter, because if you are producing in PQ and you have the SDR and you're sending PQ to your customers and you're getting the return feed from the OTT, if in the middle somewhere it was converted to SDR and back to PQ because of misconfiguration of devices, visually, in some cases, the picture will look okay for you. But on the waveforms, you will see immediately that the range is kept, that you have something in the middle that erased your very bright whites and very darks. So this is why you need to use it, in order to see that you really have this information on your feed.
So this is a pretty good segue, actually, to ask a question to the larger audience too. We are talking a lot of HDR terminologies between the PQ, and we're going to talk about LUTs here in a little bit, and so forth. And so something we've been talking about internally is we've been thinking about doing a webinar of HDR basics. It might be one session, it might be two sessions, it'll probably be pretty long, but it's like, how do live production HDR workflows work? But also kind of a primer, like what is the basics of HDR? What does all the terminology mean? And we'll go into kind of great deal describing all those. So if you all would like to, perfect timing, take a look at the poll. If you'd like to attend like an HDR introduction, an HDR primer at some point in the future, fill out the survey, because if enough people are interested in it, we would love to be a asset to you all. Again, this isn't something that we're doing to promote our product or anything. It's literally just general industry knowledge. And we have some people on our team that have an entire lifetime of knowledge in this. So we would very much look forward to it. So check out the poll if you'd like. So I guess, Tomer, if you don't mind moving forward to the next screen, which is the 4-box, I believe. Let's talk a little bit about LUTs and LUT management, because I think LUTs is probably one of the things that almost everybody is reading in the trade magazines right now, but it's also, I think, one of the most dangerous, but also most flexible parts of HDR workflow. So, what is a LUT in this scenario? Why do LUTs matter, both for the QC side? Wow, that is a very big resounding yes that people want to do the introduction webinar. So it looks like Tomer, you and I, and maybe Paul from our side will be doing another one of these in the near future. Thank you, everybody, for that opportunity. So yeah, let's talk about LUTs. Let's talk about
Okay,
why they matter and why it's on everybody's mind right now.
let's talk what it is. A LUT is, in the end, an equation of how to convert colors. All of the LUTs are talking about conversion between RGB and RGB. We're sending YUV in our industry, and in the end, the screen has RGB pixels. So a very basic LUT is just the LUTs that the screen will use in order to convert the YUVs that it receives on the screen, on the stream, into the RGB values that it needs to push to the pixels. Now, a more sophisticated LUT will be a LUT that converts RGB to RGB, meaning you're taking something and you're converting it into different colors. The equation of the LUT can do everything. You can invert colors. You can do all kind of things. It's not just tuning the colors. You can do whatever you want in the mathematics of the LUT. Now, the idea is a classical LUT will be a LUT that configures your conversion from, let's say, HLG into SDR or PQ into SDR. This is something that everybody will use because you're producing in one format and you want to have a variant of the content in SDR. So using some kind of mathematics to do this conversion. And the standard for this conversion is a LUT. And the most classical one, there's different types, but the classical one, the most common one, is a LUT based on 32 values for each RGB value, meaning 32 zones. So 32 values means 32 zones of the value times 3. So it's like a cube with 32 and 32 and 32 values for the RGB. And each pixel is placed in one of these cubes. And for each one of these cubes, there is an equation of how to do the color conversion. So if your pixel is only green, then the value for green will be 1, and the value for red and blue will be 0. So it takes a value from this cube, from this value, and doing the conversion of the color. There's lots of mathematics of how to use it and how to do it, so it will be very high quality and fluid. But in the end, this table tells you how to convert the colors. So with this color conversion, you can have a flat conversion. You can have a conversion that adds more orange to your scene or whatever. It could have incorporate an artistic decision of how you want your SDR to look. It's not just, there's no one right way of how to do it. There is lots of flavor and personal, personal taste.
Well, adding on to that exact point, actually, and also for kind of for the larger audience, most productions nowadays are being produced in HDR, and then at some point they are adding a LUT to that to create your SDR workflow. So the SDR is now being is a derivative work from the HDR workflow. And to Tomer's point right now about kind of the personality of it, this will be applicable to everybody in North America. So apologies to anybody else who's not North America, but I'm assuming everybody at some point here has listened to National Public Radio, NPR. And, when you tune into an NPR radio station, you always get that NPR sound. Their EQs on that radio station always sound the same. So it doesn't matter what NPR you look at, you roughly get the same sound. We're seeing the same in HDR in LUTs. So there's two very prevalent LUTs in this industry today, and that's NBC and BBC. And the idea basically is any HDR production that applies to NBC LUT will get video that looks in the certain creative intent of the people at NBC. And same with the BBC. You do your production in HDR, you add the BBC LUT, and then you kind of get the creative decisions or the creative intent of the BBC on that SDR LUT. So we're seeing that. And another, this does actually affect, this isn't just a North America part on this one. There is a college that did their own LUT, because they have a red on their football field that also happens to be the red on their logo and the red on their mascot and the red on everything they have. And they wanted to make sure that that color was protected no matter what. And so they actually created their own to be able to give creative emphasis, the creative drive to emphasis, there's what I was looking for, to that logo. So we're seeing that this HDR world isn't necessarily just a science. There's a lot of individual creative intent that's added to it, especially through LUTs. So, which is a very good segue, I think, Tomer, to our next discussion point is how can we create a an HDR workflow? How can we create an HDR tool set that will allow you to generate HDR content and then fax it out to your entire of your in production chain? You know, how can I say if I'm going to interject PQ at this point, that every point downstream from there is correct? Because one thing we have seen is there might be a LUT or there might be an encoder set up incorrectly. You know, we're creating a PQ with 1,000 nit or something, or HLG at 1,000 nit, but an encoder set at 700 or it's expecting 2,000 or something. So can you explain and maybe show some of the new tool sets that are out there to be able to create these HDR test environments and run it through the entire production chain?
So in this sample, we're pushing out a test pattern, a color test pattern. As you can see on the top right, it's the HLG variant, which is like the basic one generated from this RGB pattern, which again, you can send it through the MCM. The MCM can send it in all of the formats. So whatever your ingest is, 2110, NDI, compressed, uncompressed, 22-6, you can send this to your production workflow. And then you can follow how it looks down the road. Now, in this case, we are sending it 3 times. Once in HLG, once in SDR, and once in PQ. In this case, the pattern is generated in RGB and converted to SDR and PQ using the NBC LUTs. So, it's the same pattern. So this is how it would look using this conversion. So if you have an HLG source and you're converting it in your production workflow using NBC LUTs into SDR, you would expect to see the same analytics as you see on the left side. Now, if you don't, it means that something is wrong, that you have a problem. If you're not using the right LUT, or you have some device in the middle which is capping the information, or you have a conversion to 8-bit in some point and you lose data and so on, and then you'll see all of those effects on the analytics. You don't need to see the video itself in order to know if it's good or right, because you have on the vector scope, you have this shape, which shows you exactly how it should look. And if it doesn't, if it's not converted correctly, it will look differently. We don't have a sample of it here, but let's say that you see the vector scope of the PQ on an SDR source, then you know that something happened, colors are off. In this case, if this will be the vector scope that you see, also your picture will be kind of colorless. This would be a side effect.
I kind of dig this workflow because it gives everybody a very simple, easy to look at tool where you can generate it at the very beginning of your workflow, you know, at the highest point that you want to be able to be able to create this, and then every derivative work you have of that signal as it goes through. Again, as it goes, maybe it's converted to NDI or converted to SRT or converted to HLS or hits an encoder, then a decoder, or hits a CDN and gets that return. You know, we have a very simple tool that allows the operators to look at the video as it's intended at its highest quality, you know, where we're very literally generating the signal out of the mathematical values. Again, this isn't a slate. This isn't something that we are, you know, just taking a bitmap. This is actually generated from the true values and gives a very simple tool for operators to look at and say, okay, here's my original. This is how it looks. And here's my HLS return. They are not the same. Something somewhere went evil. Let's go take a look. Right? Is that, and that's, I'm guessing that's kind of the point of this tool set, is to have a kind of a simplified view where the users can just look at it and say, this is the state.
Yeah, and I'll give an example how it can happen. If, for example, you're sending a PQ content and your encoder doesn't know that it's PQ, then it doesn't know that your brightness levels are logarithmic. So it meaning that once it's encoding your content and doing the quantization of the encoding, quantization means that it really throws away information and, you know, tries to minimize the information that it sends. If it doesn't know that it's a logarithmic scale, you wouldn't get the same quality as you get if he knows that. You'll see in a scene where you have a blue sky, you'll suddenly see lines in this sky because it didn't utilize enough color depth in this range of colors. When it knows it's a PQ, he will give those more visible parts of the picture higher bitrate or higher quality as needed.
Perfect. So we have a couple questions that have come in throughout the webinar. I want to make sure that we have a chance to get to some of those. The first one that did come in, if you don't mind going back to that the single widget view that we had, the one we kind of started off that showed the detail view of all of them.
And the single.
And the double's fine, but the single will work ideally. This first question that came in is, I know we talked about the waveform vectorscopes, we talked about the histograms and so forth, but there is the one on the bottom right where we had the RGB values. There we go. Those, yes. So could you give us a couple seconds on what's the differential between the RGB broken out one here at the bottom right compared to some of the other ones?
Okay, on the bottom right is the parade display. It's like the waveform display, only for RGB channels, meaning that you take the picture, the YUV picture, you convert it into RGB, and then per component, R, G, and B, you create a separate graph. And this graphs is, you need to explain the waveform display in order to explain it. But
Yeah.
I'll go and explain on the waveform. It's easier. The waveform is, in this case, it's a luminance display. So you're scanning the picture from left to right. And for each line, you put a pixel in the brightness of the pixel. And you create a line. So if you start from black, you'll have you have a line on the zero. And then when the pixels being white, you go up to a white and then back to black if it's black, and then you scanning the whole frame, and this is what generates multiple lines on the vectorscope. So if we would analyze only a single line of the video, the vectorscope would have a single line also. This tool was invented when we had analog screens where we would send scan lines. This is why it's, this is the math of it, and this is how it's being done. Maybe if it would have been invented today, this wouldn't have been the math of this display, but this is how people are used to use it, and this is what they know. So it's the same math being implemented on a digital content where line scanning doesn't have a lot of meaning.
Got it. Perfect. One question on HDR metadata. Is the HDR metadata wrapped into the transport, or is it a sidecar that's kind of sent along with it? How does the data get transported around like an HDR 10 plus or Dolby Vision?
It's an excellent question. If you're talking about 2110, in 2110, nothing is encoded along with the video. So you have the 2110-20, which is the pixels themselves. Even the color space, SDR, PQ, HLG, is not defined in the stream. It's defined either on the SDP file or on the -40. The -40 is the place where you hold the metadata. So a common problem could be in this case that if your -40 is not in sync with your content or missing, suddenly your video will look terrible because the metadata doesn't fit the content. And as we said, a live production with HDR metadata is not so common today, so we have less problems around that. Now, when you're talking about compressed content, the metadata is encoded into the HEVC SEI headers, meaning those are headers in the it's a picture header. So you have these values in the sequence header and picture header per picture, and it's part of the content of the video. If you're talking about OTT, it's not even in the OTT init files. It's not in the manifest. The manifest can tell you, yes, it's a PQ or whatever for your player to choose the best one fitting your hardware. But in the end, the metadata and the information is encoded in the stream itself.
Thank you. The next question is there an option to have the visualization of the signal with the CIE 1931 diagram with the 2020 or the 709 triangle? So I guess that's some visualization tools we haven't quite added to our tool set yet.
We support the 2020 and the 709. We are adding more and more displays and graphics to this tool. We started from the most common features, and obviously we will add more and more and more depending on need and requirements. But those tools are kind of everything you need for HDR live production. It gives all the information it needs. You can, show it in different shapes and things, but the information is in it. You have it.
Perfect. So there's a couple other questions that came in about SDR to HDR conversion, HDR workflows as a whole. How does metadata offer through or differ throughout the workflows and so forth. I think all of that we could actually probably spend another 40 minutes answering those questions. So instead of answering them in this webinar, we can tee it up for another one we will be glad to do in the future. Again, kind of more of a fundamentals of HDR workflows and a primer for HDR. But also, all of us, Tomer and myself, another gentleman by the name of Paul Briscoe, and other people on the tag team are here to answer these questions offline. So if you would like to email us, if you want to reach out to us in any way, give us a call, send us a text message, email. Some of these questions we'll be glad to work with you one-on-one on because A, we're here, and B, we're kind of passionate about it. It's something that we enjoy talking about. So as a good segue to that, what we enjoy talking about, something that we're passionate about, kind of as a wrap, Tomer, if there was two things that you wanted to leave, for everybody here, kind of two thoughts to, it could be productive, could be not productive. It could be stop doing this, please, or we can be better, or however, if there's two things you can leave everybody with, what do you think it would be?
For HDR production, I would say that those two important things. One is to choose your set of tools and to know how to use those tools and know what to expect from those tools. So you'll have some things that know how to use. And the second is to get a very good screen, because in the end, there's no replacement for a very good screen. The things that you do see on very bright OLED screens are just not there on older screens. And all the math in the world, it's nice, it's good for the conversions and to know that you're not completely obscuring stuff, but you do need a good screen in order to produce PQ content.
My only one takeaway from this is looking at the attendees. There is some kind of executive managers of some of the networks out there. Probably the biggest thing I would personally say is spend the time and invest the time with your engineers to understand the workflows, understand the technology, and give them the time to learn. Because this is all a very new technology and it's also changing very quickly. I think in the probably past 4 years where HDR has been really big on the distribution side, we've gone from HDR 10 to HDR 10 plus to Dolby Vision. Different types, different commercial reasons are happening all the time. So if you have the chance to invest in yourself to learn about this, or from the management side, if you have the opportunity to invest in your engineers, please do that. I think it's going to be better for everybody as a whole. Okay. So if anybody has any further questions, there was a fantastic question, by the way, that just came through about automated alarms with HDR workflows. As you can imagine, that's something we're very passionate about, having automated alarms for HDR workflows, because we do it already in all the other workflows. If you'd like to talk about it or like to dive into that more at some point in the future, again, please reach out, LinkedIn, email, however you'd like. We're absolutely here to help. If you all would like to be able to play with this tool set, we're glad to make it available to you to try. Not only will we be glad to make it available for you to try, we'll be glad to have some of our technical resources work with you to get it set up, and also work with you to understand how to monitor and probe those HDR workflows in your live production environments. I just want to say thank you to everybody for taking your time out in your evenings or in your early mornings if you're on the West Coast. And Tomer, thank you for your insight and also for your the tools that you made for us and made for our customers to use. So thank you all, and I wish you a fantastic Tuesday.
Thank you.